It is called Europa, and of the three, it resides closest to Jupiter. That proximity to the giant planet means Europa's core may be very hot, far hotter than Callisto's or Ganymede's. But its surface remains frigid, a potent combination for life, since there could be a temperate zone where they meet. Mammoth fissures scar Europa's thick crust of ice, a sign that ice is always shifting. On our own planet, we see the same cracks in the ice sheets covering the Arctic Ocean. Europa's crust may be riding the largest ocean in the solar system, an ocean twice as large as all of Earth's put together.
Now those oceans, if they're there, and the chances are pretty good that at least some of them are, they've been sitting around for a long time, 4 billion years, a little longer, right? In 4 billion years, an ocean of water, do you think anything might have cooked up there? Well, it certainly seems plausible.
The environment in Europa's ocean is more or less as nice as the environment in our own ocean, as a place for living things to exist. Heck, things from planet Earth could probably live in the European Ocean.
But Europa's oceans will be very cold, even slushy. And sunlight never penetrates them, thanks to an icy cover that may be 16 kilometers thick. We might never have thought life could exist here, if not for a revolutionary discovery off the coast of Ecuador. Deep in the Pacific, biologists have found flourishing communities of tube worms, crabs, and even squid. These creatures are thriving despite complete darkness, extreme cold, and the pressure of the deep ocean. They feed on bacteria that take their energy not from the sun, but from chemicals erupting from the sea floor. We might find very similar volcanic vents on Europa, supporting their own web of life. To find out, NASA scientists would like to put a lander on the European surface. Some would like to send a cryobot, a robot that would melt the ice and release a probe into the liquid below.
That's not so hard to do. You just have to melt your way through. But you're going to have to melt your way through not a couple hundred feet, but maybe a dozen miles of ice. And send down a fishing line with maybe a video camera and a light bulb on it and look around.
In all that water, we can't rule out the possibility that very simple life forms have evolved further. We might even find creatures as advanced as some here at home. Most likely, however, we would find microbes. But even that would be a sea change in how we view the birth and growth of life. Europa was warm. What if the place is one of the coldest known? Or if its lakes flow with toxic chemicals instead of water? These are the worlds we find as our safari continues even deeper into space. As our safari in search of alien life sweeps by the ringed planet Saturn, we can see the violently swirling gases that choke its atmosphere. We can also feel Saturn's gravity, weaker than Jupiter's, but still formidable. We'll keep moving. We're not likely to find living things here. Saturn's rings are also extremely inhospitable. They're made of rock and ice, as small as a grain of sugar or as big as a house. But Saturn has many moons, 56 that we've spotted so far. Our safari heads first to one of those moons, a tiny frigid satellite called Enceladus, just 500 kilometers in diameter. Here, gravity is very weak, a fraction of that on Earth. And Enceladus has hardly any atmosphere. It reflects back into space almost all the sunlight that hits it, making it the shiniest object in our solar system. Until very recently, we also thought Enceladus was too cold to support life. It appears we were wrong. In 2005, after a 7-year journey, the Cassini spacecraft approached the tiny moon and detected something that stunned the mission's principal investigator, Caroline Porco.
So this was the picture that just, grabbed us. Just was shocking.
Those are plumes made of water from a geyser. The geyser's steam and hot water hit the cold vacuum of space and explode into a jet of ice. With little gravity to rein it in, the ice cloud can grow as big as Enceladus itself. Porco has never seen anything like it anywhere else.
It's like a planetary explorer's dream to come upon a body like Enceladus. Those jets, those fountains, if you will, just spewing vapor and icy snow hundreds of kilometers above the south pole of Enceladus.
There's only one conclusion. Tiny, frigid Enceladus is piping hot within. Like Jupiter, Saturn's giant gravitational field tugs on its satellites, creating friction and heat within.
As far as we can tell now, it seems like an inescapable conclusion that there may be liquid water deeper down on Enceladus because it's warm. And the best models we can put forth right now to even explain the warmth, much less the jets, seem to indicate that you would get temperatures warm enough to melt water.
Heat, liquid water, even the furthest reaches of our solar system may contain the chemistry for life. What kind of creature could live in the steamy waters of a geyser? Thanks to hot springs back on Earth, we have some idea. At one point, we assumed nothing lived in the steam-driven fountains of Yellowstone National Park. But then, biologists discovered microbes in these waters. Microbes that feed on chemicals dissolved in the water. Today, we call them thermophiles. The hardiest can thrive in boiling water. Could there be thermophiles on Enceladus? To find out, our safari takes us in for a close-up of this extraterrestrial Old Faithful. It's too cold for anything to live near the surface, but temperatures there are minus 165 degrees Celsius. But what about the hot water inside? In the ice plume above Enceladus, Cassini's probes have found carbon dioxide and methane, chemicals that could feed life below. Just as the chemical-laden springs of Yellowstone feed microbes living there.
We have a body that very, very likely has liquid water in its interior, has shown us already it's got simple organic compounds, and a whole host of things that make it, I think, a major body of astrobiological interest in our solar system.
If Enceladus has been a shock, astronomers have been astounded by another of Saturn's moons, Titan. It may be the unlikeliest to harbor life. Titan gets only a limited amount of sunlight, about 1,000th as much as Earth. Probes sent to Titan have detected ice, but no liquid water. And at temperatures of minus 138 degrees Celsius, that ice is hard as stone. What could possibly make Titan a promising environment for alien life? Remarkably, Titan in many ways resembles the Earth, but not the one we know now.
Titan has turned out to be the body fantastic in the Saturn system, which is long suspected of having an environment at the surface, not only similar to the kind of environment we find here on Earth, even, believe it or not, similar to the kind of environment we had on Earth before the emergence of life.
Titan intrigued Caroline Porco's team so much, they directed the Cassini spacecraft to send a probe there in 2005. It was the most distant surface mission ever conducted. The probe saw just ridges and plains. But a later flyover by Cassini spotted a shoreline. Soon, thousands of lakes came into view, at least one bigger than the Great Lakes of North America. It's the first time we've ever detected liquid on the surface of another celestial body.
Kind of looks like Minnesota, except the lakes are not water. They're liquid natural gas. But liquid natural gas is a liquid.
And that's not snow. Those are methane flakes. Like Earth, Titan has weather. But it's of a rather psychedelic kind. There are even methane hurricanes.
It's not water, it's methane, doing all the exact same things. Raining, evaporating, flowing in rivers. So you have something that is basically doing what water does on Earth. On Titan, only it's methane.
A similar scene may have existed on Earth 4 billion years ago, making scientists suspect that Titan could also be an incubator for life.
Chemistry does go on. At those cold temperatures, it's really slow. But Titan has had 4 billion years in which to do some chemistry, and maybe in that period of time, maybe something is cooked up.
It would have to cook up without liquid water, something we've never seen before. But scientists aren't ruling it out. The substitute could be the methane, so abundant on Titan. Used for fuel on Earth, methane was long thought poisonous to all life. But in 1997, researchers examined mounds of methane ice in the Gulf of Mexico, and they were astonished to find colonies of small centipede-like worms thriving amid the frozen substance. They think the worms may eat bacteria that feed on the methane.
In general, things that we think of as deadly, many of them are potentially lively. If you can figure out an evolutionary way to tap into that energy rather than having it destroy you, then it can be bountiful.
There could be one more complication for life on the surface of Titan. With only a weak magnetic field to shield it, living things on the surface could be exposed to cosmic radiation. But that might not be a problem for an extremophile, as we found here on Earth. Biologists have uncovered plenty of life near Chernobyl's contaminated nuclear reactor. And even swimming in toxic radioactive spills, actually feeding off the decaying molecules. It's possible Titan's life forms could do the same. To find life on Titan, we may have to dive into its methane lakes, where we might find chemical-loving bacteria